Hello children, welcome back to our physics adventure. Today we are going to explore how electric current travels and how cells and batteries provide energy. What makes a material good conductor and how an insulator stops it. So by the end of today's class, you will see electricity as a whole new way. So let us get started. First of all, let us start with cell. To understand the concept of cell, let us consider a small example. For this, let us consider two spheres. One sphere, let me name this as A, the other sphere, let me name it as VB. Let the potential across A be represented as VA. Let us consider it as some 10 volts and the potential across B be some 4 volts. So clearly A is at higher potential whereas B is at lower potential. So whenever these two spheres are joined with the help of an electric wire, the electron starts flowing. The electron starts flowing from the sphere of lower potential to the conductor of higher potential. So whenever two charged spheres are connected as shown in the figure, one maintained at higher potential, the other maintained at lower potential, electron starts flowing from the conductor at lower potential to the conductor at the higher potential. So how long this process is being continued? As and when the electrons are moving on, the potential of the conductor B starts increasing. 4 will become 5, 5 will become 6, 6 will become 7 and so on. And because the electrons are being moving to the other conductor, first conductor, they will get neutralized. And as a result, the potential across the conductor A decreases. So, the potential across A starts decreasing whereas simultaneously the potential across B increases. This process is continued until the potential at both the conductors became equalized. 10 becomes 9, 9 becomes 8, 8 becomes 7. So 10 and 4 initially it was 14 volts. So now after connection this 10 volts will become 7 volts and here also will become 7 volts. 7 and 7 again it is 14 volts. Okay. Now if you observe, what is the potential difference? The potential difference across A and B is given by VAB equals to VA minus VB is equals to 7 volts minus 7 volts is 0. So, what we observed is whenever the two charged conductors, one maintained at higher potential and the other maintained at lower potential are connected with the help of a charged wire, then the higher potential will be decreased whereas the lower potential gets increased until the potential between the two conductors becomes equal and the potential difference will be 0. Okay, and this process is a quick process, immediate process. But what if you want to maintain some constant potential difference across between the two conductors? We need to introduce a cell. In order to maintain some potential difference between two conductors, we have to apply cell over there in order to maintain that constant potential difference. Here goes your concept. So what is a cell, children? Generally, let us picturize this. How does a cell look like? This is how a cell looks like that we generally use in the TV remotes, any remotes, AC remotes, TV remotes, watches, wall clocks and all. We will be using a cell. Okay. The cell, one end it consists of a cap-like structure, the other is plate-like structure. The end which has a cap-like structure is generally taken as your positive terminal, whereas the flat end is taken as your negative terminal. So as a result, it maintains some potential difference across its two terminals. Okay. So between the two terminals of the cell, some potential difference is maintained. What exactly a cell consists of? A cell consists of some chemical inside. Inside, what is there? Some chemical is there. Because of this chemical, some reactions takes place. And these reactions gather all the positive charges to one side, whereas all the negative charges to the other side. These reactions occur in the cell because of the chemical present inside the cell. The terminal where all the positive charges are accumulated are named as positive terminal, whereas the end where all the negative charges are accumulated are named as negative terminal. So this will become your positive terminal, the cap-like structure, whereas the flat plate-like structure becomes your negative terminal. The general cells that we use in your daily life generally maintains a potential difference of 1.5 volts. The normal cells maintains a potential difference of 1.5 volts. And these cells that we generally used are called as your dry cells. What are they called as, children? Dry cells. Okay. So, if you consider too many cells, combination of cells if you consider, then we can increase the potential difference. So, suppose if you consider that only one cell maintains a potential difference of 1.5 volts, then two cells can maintain a potential difference of . So, if each cell can maintain a potential difference of 1.5 cells, two such cells combine together, then if this is 1.5 volts and that is the other is 1.5 volts, together they maintain a potential difference of 3 volts. Similarly, if one more cell is being replaced, again we have one more 1.5 volts. 3 plus 1.5 again 4.5 volts are maintained, and hence in order to increase the potential difference between any two terminals, the number of cells are being increased as shown. So this is called as a combination of cells. Okay. So the combination of cells, it can be two or more than two cells combined together to give a larger potential difference together is named as your battery. What is it called as, children? Battery. Number of cells combined together. So this is called as your battery. The general notation, the symbolic representation of a cell is something like this. In circuits, the cells are represented like this. The one with the longer line is called as your positive terminal, whereas the other with the smaller line indicates your negative terminal. So if you would like to connect a large number of cells, so one cell, second cell, third cell, so on and so forth. This cells, if they are connected in series, something like this. Okay. So this together is called as your battery. Well, so now let us try to understand the electric circuit. Electric current inside a circuit. Here we go. Consider a circuit as shown in the figure. So what is exactly a circuit means? You have to consider a metal wire. So a metal wire is bent in this format. The blue color whatever is there, let us suppose that blue color indicates a metal wire in that structure. For the two ends of the metal wire, for the two ends of the metal wire, let us suppose that a cell is being connected as shown in the figure. So whenever a cell is being connected to this metal wire, we observe that some potential difference is maintained between the two ends of the metal wire. So whenever such process is carried on, this terminal is maintained at the higher potential positive terminal, this is maintained at the lower potential negative terminal. As a result, the electrons, we know that inside any metallic conductor, there are large number of free electrons are available. So these free electrons starts moving. These free electrons start moving from the positive terminal, from the negative terminal. This is your negative terminal. The electrons come out from the negative terminal to the positive terminal in the metal. Okay. And these electrons when reach this positive terminal, because of the chemical that is present inside the cell, it drives those electrons again to the metal plate, negative side. Again when it comes out, these electrons outside the cell, inside the metallic wire, they will be going in this direction, and when it reaches A, again they are driven to the other side. Okay, and this process is being continued. So what makes it actually happen? So these electrons inside the free metal, there are large number of free electrons are there. So these electrons always travel from the negative part to the positive part. Inside the cell, because of the reactions inside the cell, these electrons are again driven to the other side. As a result, the electrons start moving continuously. So whenever the charges, electrons in the sense charges, whenever the charges flows continuously in one particular pattern, we say that electric current is generated or electric current flows in the circuit. The electric current flows inside the circuit. Okay, but generally, as we know that even though the electrons are moving from B to C and again to A, B, C, A, the electrons are moving from B to C to A in this particular direction, that means anti-clockwise direction, but the actual current is supposed to be flowing from A to C to B. The actual current, the direction of the actual current will be from A, C, B. So conventionally, though the electrons moving from the B to C to A, but the current will be flowing from A to C to B. So as if it appears as if the positive charges are moving inside the circuit. So conventionally, if you consider the direction of the direction of the current is taken as the direction of the positive charges. Okay, so current must be moving in this particular direction, in the clockwise direction. Electrons in the anti-clockwise direction, whereas current in the clockwise direction in this particular picture. Okay, hence according the conventionally or the conventional current is supposed to be flowing from the positive charge to the negative charge, even though there is only electrons will be in motion which is in the reverse direction. I hope the concept is clear, children. Okay, so now let us try to understand how this current is being measured. So the next topic is something regarding the measurement of current. How the current is being measured. current generally indicated with the letter I. Okay. So, this current is the amount of charge flowing per unit time. The amount of charge flowing per unit time is defined as our electric current. Charge, I told in the beginning, indicated by Q, whether capital Q or small q, upon time. Charge per unit time. The flow of charge per unit time constitutes your electric current. Okay. Well, so moving to the units. Charge is measured in coulombs. Charge is measured in coulomb. Time is measured in seconds, whereas electric current is measured in amperes. So clearly 1 ampere, symbolic notation is A, is equals to 1 coulomb, symbolic notation C, upon 1 second. So how do you define ampere, children? 1 coulomb of charge flowing through per 1 second is considered as your 1 ampere of current. So the rate of flow of charge is simply defined as our electric current, or the charge flowing per unit time is called as your electric current. Units of electric current is ampere, units of charge is coulomb, whereas the unit of time is T. Hence 1 ampere is equals to 1 coulomb per 1 second. Is that clear, children? Well, so children, if you consider any cell, okay, as I said that one side it is maintained at this is a positive terminal and this is a negative terminal, and we observe some potential difference between the two terminals. And how much the potential difference for the normal dry cells? The normal dry cells that we generally use for the household purposes and all will maintain 1.5 volts of potential difference across the two ends. Okay. So this is called the potential difference. So a cell is generally used to maintain the potential difference. Okay. Well, so let us also try to understand something regarding the conductors and insulators. The next topic is something around the conductors and insulators. What makes the difference between the two? So what are conductors, children? Materials that allow electric current to flow through them is called as your conductors. Okay. Simply, the materials that conduct electricity are called as conductors. The materials that allow electric current to pass through them is called as conductors. And the materials which does not allow the electric current to pass through them is called as your insulator. So what makes the difference between a conductor and the insulator? If you consider a metal generally consists of large number of free electrons. A small potential difference is applied means between the two ends of a metal means, as I have given you in the previous example. So the electron starts moving from one edge to the other corner. Okay. So these flow of electrons generally constitutes a current. So all metals as they consist of large number of free electrons, so almost all metals are considered as a good conductors. Similarly, if you consider in insulators, in the insulators these electrons are tightly bounded to the respective atoms. So there is hardly any impossibility to free those electrons. So as these insulators do not consist free electrons, it does not conduct any electric current. So some good examples of a conductors are metals. Among the metals also, almost all metals conduct electricity. Okay, but among metals also silver is the best conductor of electric current, but as we know that silver is a precious metal, a costly material. So Instead of silver, we will be replacing it with copper or aluminum for conducting electricity. And coming to the insulators, insulators are something like plastic, wood, porcelain, glass. These are all non-metals. Okay, most of the non-metals and these are insulators. But insulators, even though they do not conduct electricity, they do not allow the charges to flow through them, but they are also helpful during this. These are generally used to insulate the metal wires. Okay, that's it. Well, so these are the differences between the conductors and insulators.